Hey, Joe from Coding Blocks here. It's been a little while. Sorry about the delay. I blame it on Hurricane Matthew. Anyway, I'm back trying to do more of these videos. I got some good feedback about it, and I am going to try and keep it shorter. But other than that, just going to keep doing what I've been doing. Last episode, the last video, I promised I would take a look at some articles and try to kind of take some of the common hints and tips for doing this sort of thing and try to implement it. But I had bookmarked a lot of articles, but unfortunately, a lot of them, not like they're bad, but unfortunately, they just weren't what I was looking for. I was looking for something more like this that I found on simpleprogrammer.com from John Sonmez. I just basically gave nice little outline for how to specifically do this very specific part of the technical interview. A lot of the stuff I found was more kind of I don't want to say fluffy because it's not bad. It was more meta, things like ask good questions and pay attention and get good sleep the night before, whatever, which just not what I was looking for. So I am going to try and keep these guys in mind. I'm going to try and read the problem twice. I'm going to try and solve with some sample data, which is easy to do on Code Wars. Take a pass at optimizing, um, writing the manual steps, replacing comments, and optimizing. And he does say at least 70% of the time should be spent in the first 3 steps. So, and she mentioned that these are the first 3 steps without programming. So just kind of making sure you really got a good grasp of the problem, that you can do the problem before you try to actually program it. And I know that's something I've had a problem with before because sometimes I'll start to do a problem and I'll solve part of the problem and think I'll get to the next part later, or I'll deal with this part of the equation later. And I paint myself in a corner and I just get in a bad spot. And rather than start over, I tend to just kind of keep digging myself out of the hole, which doesn't work very well. So anyway, back to Code Wars. Let's find an easy one. All right, joyful numbers. So if you remember Jason Thomas's blog here, the first thing we want to do is read the problem twice. So positive integers that are divisible exactly by the sum of their digits are called Harshad numbers. There's a link. First few numbers are 1, 2, 3, basically everything up to 10. Then we skip 11 and then 13 through 17. I'm going to read this already again before I even finish. Positive numbers divisible exactly by the sum of their digits. Okay, so 1 is equal to 1. 10 is, or sorry, 1 is divisible by 1. 2 is divisible by 2. 10 is divisible by 1 plus 0. 12 is divisible by 1 plus 2. So yeah, 4. Okay, so I got that. Because there's a sample number here, 1729. You take the digits, 1 plus 7 plus 2 plus 9, you get 19. And you divide 1729 by 19, and you should get 91. So next part of the problem. We are interested in Harshad numbers where the product of S and S with the digits reversed gives the original number n. Continuing with the above example, reversing S, that's that 19, gives 91, and 19 times 91 equals 1729. Write a function number joy which tests if a positive integer n is Harshad and returns true if the product of its digit sum and its digit sum reversed equals n, otherwise false. Okay, so I'll spare you me reading this all out loud again, especially because I'm not a good reader out louder. But basically, we want positive integers, Harshad numbers, that are divisible by the sum of their digits. So like 18 is divisible by 1 plus 8. But 18 would not match the numbers that we're looking for because, well, actually that's not true. That's an interesting case because 1 plus 8 is 9, it's a single digit number. But yeah, sorry about being confusing. There's no case where a single number times a single number is going to be equal to something like any number less than 20, that's going to be a single number. So I think I said that all wrong, but hopefully someone understands what I mean, and hopefully I'm right. So let's give it a shot. Wait, why are we doing Python? All right. Now I am going to read the problem one more time because I just realized that I started kind of getting sloppy on the details and decided to just pass on it, which is the exact opposite of what Johnson Somnez is suggesting here. I want to read the problem completely twice, and if you look at this article again, we'll have a link in the description here. He goes on to explain each step and spends quite a bit of time talking about how you really need to understand what you're doing before you start coding, which makes a lot of sense. So we want the Harshad numbers, which are divisible by the sum of their digits, and we want the joyful numbers, which are Harshad numbers, where the number is equal to its Harshad sum multiplied by the reverse of that Harshad sum. Hard thing to say, which is I guess why it takes a couple sentences here. So let's think about solving this manually now. And step 2 from John Sonmez is to solve the problem with 3 sample sets of data. So I'll do a single digit. We'll do something, their example, and I'll just pick one, and maybe it is, maybe it isn't. So 1, take the digits, add them up. 1 is divisible by 1, so it's a Harshad number, and 1 is equal to the digit times the digit reversed. So I would think that 1 is a joyful number. If we look down here in the test below, we can see that's correct. 1729. Math is hard, but let's see if we can do this. 8 plus 2 plus 9 is over here, so it's 19. So 19 times reverse, and we know over here that it's going to be equal to 1729, and 1729 is in fact a Harshad number. So let's try 1, 2, 3, 4. I'm guessing this is probably not. I just kind of picked it out of a hat, and this seems like a pretty unlikely chain of events, so hopefully this is not one. So 1 plus 2 plus 3 dot plus 4 is equal to 10. And the number is not divisible by 10, so it's not a Harshad number. So let's take a look at one of these other guys. 1997. Oh, he said to do it 3 times. Sorry, stopping at 3. Okay. Now let's optimize the manual steps here. So what did I do? Let's take a look at this 1729. That's a good example. And let's write it in pseudocode. First thing is I broke the number into individual digits. I added them up and then checked if n was divisible. I guess I could just say if n is divisible, then okay, I'm going to set s there. So if n was divisible by s, then if s times reverse of s equals n, then true, otherwise false. So we solve the problem. Now we're going to optimize these steps a little bit. Anything we can do here, add up the steps. Kind of wondering if we even need to bother checking to see if it's our Harshad number in the first place. I almost want to just say if s times reverse of s equals n, then we know it's a hard-shot number, and it's just a little bit simpler. And then we could just say return that. So I think that's pretty good. Yeah, not really able to think of anything else fancy to do to make that any better. I like those steps, I'm comfortable with that. Sorry about the construction noise, hopefully you don't hear it. Oh, I already did number 4. I wrote the manual steps as comments. Now we're at the part where we replace the comments with real code. Alright. So, somehow every Code Wars problem ends up involving a split. So let's take that number, convert it to a string, split it by basically nothing. Now we've got an array with each digit. So 1729, we've got a 1729. Now we need to add those guys up. If I was more up to date on my JavaScript, I would just do some sort of map summation kind of thing, but I don't know much about Node version 6, so I'm going to do it the old-fashioned way. Or at least attempt to. Alright. I don't like using single letter very well. I'm just going to change it to sum instead of s. So I guess I should bring these guys in over here too. Why make life harder for ourselves? Sum start at 0, and as we go through, digits at I. And I'm not sure how this is going to work because the digits at I is going to be a character, so I probably need to parse it here. So let's just go ahead and write it like that. And I'm going to look up real quick if parseInt is actually the method I'm looking for. It is. Woohoo. Thought it might be like a parse number or something. Alright. So now we've got the sum. And we're going to return s times reverse of s. Ah, so interesting. If sum is equal to reverse of sum, nope. If sum times the reverse of sum is equal to that number that we got passed in. Now I don't have a function for reverse, but I'm about to make one. And I'm about to make another little helper function as well. Say, call it sum digits. So I'm going to take an array of digits, and I'm going to do this. Alright, so we created a sum, we loop through here, we add up the sum, and we return it. So now I can say sum of digits. So a little bit easier to read there, but also that lets me do a part of the work I need here for reversing the sum. So first, I need a function for, we'll just call it sum of reverse, taking some digits, and I'm just going to be lazy. Hey, wait a second. That's not what I want to do at all. I almost made a big mistake. So I was thinking I needed to actually reverse the digits and add them up, but addition is cumulative, so it's going to have the same result. So that doesn't make sense. I really just want to reverse the digits, and so this work was just superfluous. So I'm just going to leave it though because it's more readable. Whatevs. We've got a step coming up for optimizing, and so what I really want to do is just reverse a number n. And so what I want to do here is very similar to sum of digits. We're definitely going to refactor this guy, but let's just go ahead and start out here. Split into digits. Now this time, instead of summing things, I'm going to start at digits.length. And I'm going to work backwards. And we're going to subtract. And I'm just going to put them in a new array. This one seems harder than a 7, doesn't it? And we'll leave some feedback. So now we've got our reverse digits. So now let's join them into one big string, and we're going to return that string as an integer with parse int. I don't like that it's not highlighted. Makes me nervous. Alright. Man, what a mess, huh? So, if sum times reverse number sum equals n, then we're true. So let's go ahead and run a test. Alright, first time. Woo! Let's go ahead and do an attempt and see if we got it. Alright, so we actually typed this right the first time. So now, thanks to these tests, it's really easy to do a refactor and feel good about it. So let's do that. First of all, this looping here is very similar, but I don't think really that's worth refactoring. And in fact, I like that, this algorithm breaks into 3 lines, which line up the 3 lines the 3 comments that I wrote. Let's get rid of those guys. So maybe I won't be doing much refactoring overall, actually, after all. So I'm pretty happy with the number joy method itself. I know there's some cool, functionally type I can do for the array there, but overall I'm okay with it. And even this stuff, I think I'm okay with it. So let's be done. All right, well, let's see how much better other people did it. Oh my gosh, look at this. Oh, there's already a built-in reverse method. Dang it. And reduce is the name of the function I was using, where they use the sum. So they start with the 0, and they add up. I'm not sure what that syntax means. That's kind of crazy to me. But I assume it's doing what I expect. That's where you get your S. This is where you get your S reversed, which is very similar. So I've just got that reverse back in there. And interesting, this join method will return a string. So SR is a string, but I guess JavaScript knows to coerce that string and treat it as a integer. So that's pretty cool. Because of that, I'm not going to give it a best practice mark, but I will mark it as clever. So that's it. Hope you enjoyed.